Hello everyone, welcome back to the series of Pandas. In my previous two videos I have discussed on pivoting, and in this video I will specifically discuss on sorting and aggregation. Sorting refers to arranging values in a particular order. The values can be sorted on the basis of specific column or columns and can be in ascending or descending order. In a capsule, sorting means to arrange the values in ascending or descending order. Sorting in Python Pandas can be performed with the help of sorting_values function. So we can use this sort_values function to sort our values in DataFrame. So this is the basic syntax of sort_values function. So we will use the DataFrame object along with the dot notation and sort_values function. It basically accepts the following 6 parameters. The first parameter it accepts is by, and the second one is axis, the third is ascending, and the fourth is in place, the fifth is kind, and the sixth one is any_position. Now let us try to understand the parameters. The first parameter that it accepts is by. So by accepts string or list of string. So these are the two parameters that it accepts. Either it can accept string values or list of string values. So we can sort the names or the list with the help of by. So we can assign the name of the column to by which is to be sorted. The second parameter which it accepts is axis. So on the basis of the axis we can also sort the values. As of now we already know that Python accepts two kind of axis, that is axis 0 and axis 1. And ascending accepts two kind of parameters, either true or false, which is again boolean type. So if we need to do the sorting in ascending order, we will pass true, and if we need not to do the sorting in ascending order, that is descending order, we will assign the value of ascending to as false. And the next parameter that we have is in place. So in place it accepts a boolean value, that is true or false. So if we assign the value of in place to as true, it will return none, and if we assign the value of in place to be as false, it will return a copy of the object with the operation performed. The kind parameter basically helps us to determine the algorithm, or basically allows us to choose our algorithm. So on the basis of our algorithm chosen, it will sort. So we need to choose a sorting algorithm in order to perform our sorting. So by default the function sort_values uses quick sort. So if we need to change this sorting algorithm, we can assign the value of kind to be as quick sort, merge sort, heap sort, and etc. The next parameter that we have is any_position. It accepts two kind of parameters, that is first and last. By default it is last. If we assign the value of any_position to be as first, it assigns all the nans at the beginning, and if we assign any_position to be as last, what it will do is it will put all the nans at the last or in the end. So this was all about the parameters that are accepted by sort_values. I hope it is clear. Now let us try to understand sort_values with an example. In this example, as you can see, I have imported two modules. One is Pandas and one is NumPy module, and I have created a data frame which has a column A, and I have created a dictionary element, and this is the key of the dictionary, which is A, and these are basically the values of this particular key. And what I have done is I have assigned this dictionary to the data frame. So this we have created a data frame with a single column, that is A. Now let's print this data frame. So as soon as I print this data frame, you can see I have rows and columns. These are basically the index labels, and this is the column that we have A, and the values that gets printed is basically unsorted. And we also have nan in our data frame. So how this nan came? We have used the NumPy module to create nan elements, that is not a number elements. So we have used the alias name of NumPy, that is np, and we have created two elements of not number. As you can see, this is the second last and this is the last element, which are nan. Now let us try to sort the elements of this data frame using sort_values function. Now let's say I need to sort the values of column A. So what I need to do is I need to assign by to as A. So since I need to sort this data frame on the basis of the column A, therefore I have passed the value of this column A as by. Now let us execute this code in order to understand better. As you can see, this was our actual data frame, which is unsorted or which is not in a sorted manner, and this is our data frame which is now in a sorted manner. So with the help of by parameter, what we have done is we have assigned the column A to by, and we have sorted the values or each and every element of this data frame as per as our column A. Now let us try to understand the second parameter, that is ascending. By default we know that the sort_values print the values in ascending order. Now if we want these values to print in descending order, what I will do is I will assign the value of ascending to as false. Since we know that ascending accepts two kind of values, that is true or false, that are boolean. As you can see, we got the values printed in descending order. So if we assign the value of ascending as false, It is to be noted that by default sort_values prints the data frame in ascending order. Now let us try to understand the next parameter. The next parameter that we'll understand is in place. So in place by default is set to false. So if we set to true, we won't be able to print the data frame. So if we set the value of in place parameter as true, it won't print the data frame and it will return none. Let's omit this part. So if you execute this code, you will see it is printing none. Since we have set the value of in place as true, therefore we are not getting the output of this data frame. The next parameter that we'll understand is kind. So kind will allow us to use our sorting algorithm as per our choice. We already know that sort_values by default uses quick sort. So if we need to change the default sorting algorithm, we will simply assign the kind to a different sorting algorithm. Since this lecture series is completely based on Python Pandas, we won't be discussing on algorithms. We will have a different series on algorithms. I know it is very hard to determine the change as we change the sorting algorithm, but in order to understand the algorithms, we will have a different lecture series. The next parameter that we have is na_position. So as soon as we put the na_position or use the na_position and set the value to be as first and last, so what it will do is it will manipulate the position of nan. So by default the value of na_position is always set to last, therefore the nan always gets printed in the last. If we need to change the position of nan to the beginning, we can do that simply by assigning the value of na_position to first. Let us execute this code. So you can see nan got printed in the first. So this way we can manipulate the positions of nan. So this was all about sort_values. Now let us try to understand aggregation. So aggregation in Python Pandas can be calculated using the following function. I've already discussed about count, sum, mean, median, minimum, maximum and variance in my previous video. In this video I will specifically discuss on standard deviation and mean absolute deviation. So in order to calculate the standard deviation, we have to use the std method or the std function. So this is being associated with the dot notation and the data frame object. So let us understand this better with an example. In this example, as you can see, I already have the data frame. So let us try to calculate the standard deviation of the first column, that is A. So in order to calculate the standard deviation of the column A, we will use the data frame object along with the dot notation and the std method. So let us try to execute this code. As you can see, this is the data frame that we have, and these are the elements of the data frame, and this is the standard deviation of this entire column. We can also use the x parameter in standard deviation, as well as we can use the LOC array in standard deviation. The next function that we have is MAD, that is mean absolute deviation. So in order to calculate mean absolute deviation, we will use the data frame object along with the dot notation and MAD function. So this accepts two kind of parameters, that is access and skip NA. By default both of them are set to none. Now let us try to calculate the mean absolute deviation in Pandas. So in order to calculate the mean absolute deviation, we will use the data frame object along with the dot notation and MAD function. So what it will do is it will calculate the mean absolute deviation of this data frame. So let us try to execute this code. As you can see, this is the mean absolute deviation of this entire data frame. Here also we can use the LOC array if we want to mention a range of particular rows or columns. So this was all about sorting and aggregation. I will discuss the other model of Pandas in my next video.